Every breakthrough begins with silence, a moment of focus, a moment of building in quiet. But in that quiet, inside these fabs, the momentum has been rising. See, quiet doesn't mean stillness, because here, progress never pauses. It pulses, pushes, accelerates, layer by layer, line by line, gate by gate. And now, it's ready to meet the world. Progress never pauses, and neither do we.
This is Core Ultra Series 3. The first processor built with 18A technology, the most advanced process in the world. We've taken big steps in improving our major SoC IPs in virtually every piece of the chip design, bringing the latest and greatest on all fronts. We have new E-cores, brand new P-cores, a massive GPU with built-in ray tracing, and an NPU that packs more low-power AI in a very dense area, much denser than prior generation. Next-gen memory, next-generation I/O, and the latest connectivity, wired and wireless. These were all done to achieve a primary goal with our partners to scale power efficiency leadership, performance across all workloads, expanding our graphics capability, I can't wait till you see this, and enabling a broader set of devices with our OS partners, with our ODM partners, our OEM customers, and importantly, the ISV community. Together, we've nailed these goals with Core Ultra Series 3. Achieved by combining the performance and power efficiency we launched across our Series 2 family of processors into one single product. And this isn't marketing speak. We will show you how it's deeply architected into the SoC through our fabrics and with our 18A process node. We've used the power efficiency of Lunar Lake as the architectural foundation of Series 3 and our roadmap moving forward. The graphics performance was already impressive, but we wanted to expand performance available across more devices. We've moved the GPU tile to its own chiplet. And now we can attach larger or smaller chiplets based on the market segment needs and the device needs of our customers. We're continuing to push through our hybrid core strategy, redesigning cores for 18A so they operate at significantly lower voltage. It means greater per-core performance while increasing efficiency. We've improved the multi-threaded performance of Series 3 by adding up to 8 E-cores, and we completely redesigned our low-power island with dedicated low-power E-cores with their own cache that run hundreds of workloads that are optimized for maximum battery life. Examples like web browsing and video conferencing that demand power efficiency. The benefit, better performance, much lower power, longer battery life. We've also consolidated all the IOs onto a single chip. This was a big ask by our customers' design teams because they want to take Series 3 and expand its capabilities and its market coverage. But people don't buy SoCs, and we know that. So beyond the SoC, we've deployed other technologies at the platform level focused on power efficiency. Intel's intelligent display technology, context-aware charging, low power video conferencing with our image processor, long-lasting connectivity with Intel's Wi-Fi solution. We bring this all together with our advanced Foveros packaging technology, delivering a full range of Series 3 processors. That architecture flexibility allows us to provide multiple configurations using a single package type up and down our customers' designs, something they've been asking for 2 generations. They have more memory options, and they now can use their own power delivery schemes for their product management and product capability. This gives them design flexibility up and down their product lineup, supporting them into the market in easing design efforts for their teams. So we just covered a lot on architecture. Let's unpack what it can do, starting with the x86 core. We're proud of this accomplishment. Core Ultra Series 3 delivers 60% more performance than Lunar Lake Series 2. And it's faster and more efficient than our highest performing SKU, running fewer P-cores. This focus, this maniacal focus our design teams have on power efficiency and the implementation of the low power island dramatically improves a range of applications we use every day. A simple example would be streaming 4K video on Series 3 draws now 1/3 the power than prior generations. A massive reduction that allows us to be talking about battery life in days, not in hours. It once again puts the myth to bed that x86 can't be power efficient, even at higher performance levels,